Unstable connection to the server. What the? What? I dropped. What? 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 Sure. Okay. Hello. Good afternoon. Welcome. Come in. Fasten your seatbelts. Put your phone to silence, please. Appreciate it. So, welcome to 6-Man working group. I hope you're all in the right room. Where else could you be? So, we have busy agenda, so I'm trying to start on time and be quick. So we have more time for presentations. First of all, note well, it's just Monday, so I guess you have not seen it yet. No? Okay. Take your time, check it, remind yourself about good behavior here, be nice to people. Well, you read it, right? So, housekeeping. I have few minor requests. Please, even if you are in the room, try to use the on-site tool to join the queue. It's much easier for the chairs to track the order of people in the queue if you are all in the virtual one, because otherwise it's pretty hard to remember who was the first. And after you asked your question or made your comment, please leave the queue when done. And state your name so the minute taker, thank you, Michael, could correctly record your, what's going on? I heard it too. Okay, so okay. Yes, and remote participants, please keep your audio and video off until you're actively speaking, which means you are presenting or you are the first in the queue. Recommended to use a headset, but well, up to you. So, agenda. As usual, we're gonna start with working group documents. We have 55 minutes allocated for that. So it's 4 drafts, including Tom's draft, which has been revived. Tom brought it back from dead. We're discussing hop by hop processing, then again extension headers. I love this agenda. SR segment identifiers draft, and VTN information in extension headers again. Then we have 6 individual drafts. I'm not gonna read this out loud. You know where to find the agenda, right? We have 2 talks in time permitting category, which means, yeah, if we will be very efficient today and have additional time, we can discuss 2 drafts. If not, authors would like to get 6-man attention on them, so please check them out anyway. What happened since Philadelphia? Oh, we published an RFC, congratulations, Bob and Gory, on MTU hop by hop option. We are making good use of extension headers finally, right? We're finding use cases for them. Application for alternate marking and now in RFC editor's queue finally. So should be published soon. Your zone identifiers draft, it's going through another round of review. We finished IETF last call, got some good comments, and now we have request URI review and W3C review to get more eyes on the draft. So it's basically, what is going on? Okay. Yeah. Share again. You getting the same, right? I'm getting the same. So it's not just me. Okay. And Suresh will be presenting his draft, which kind of out of the working group last call, but we need more cooperation with Spring people, so we'll talk about that later. We have a working group document. Okay, sorry. Let me try another SSID. V6 doesn't work, right?
I dropped again too.
That's called dog food. I don't know, 2000 probably, right? IPv6 is hard. Let's go shopping. Okay, now, where was I? Yeah, so working group drafts. 4 of them are presented today, and there is one draft which is still a working group draft, but we have not heard anything from the authors, no updates, don't know what's going on there. And the last thing, as you might have noticed, we are talking a lot about SRv6 in this room as well. So we started to think how much can we duplicate the work and how shall we share responsibility between 2 working groups here. So just to let you know, there is an ongoing discussion between 6-man and Spring. Oh, so it's not V6. I dropped off and I was on dual stack SSID. Okay, so we're talking about what shall we do, because obviously SRv6 has something to do with IPv6, so sometimes 6-man involvement might be required. However, the question is at which stage and how much of that involvement. So the current proposal, which is still under discussion, is that maybe Spring should be responsible for SRv6 work, and after a particular draft gets enough interest in Spring, I use the word adopted, but not adopted in IETF meanings, but just get enough interest and looks like a problem to solve. And if 6-man review is required, then Spring chair could talk to us, and this working group might take a look at the draft. This would that would allow us to avoid the situation when we get in a lot of Spring SRv6 related document here without even knowing if the problem is worth solving from routing perspective. So that's all I have. Any last minute comments, agenda bashing, complaints? No. Good. So then first presentation is Bob, you? Gory. Okay, I'll share the slides.
I'll stand up there.
Stay in the pink box.
I don't know. Do you want to sit down, Bob?
I'll sit down.
Oh, hi, I'm half of Bob and Gori. I'm Gori. This talk, let me get stable with my glasses. This talk is about the hop-by-hop option processing draft. Next slide, please. So we've progressed this to Rev 4. There are some open issues we'll talk about in the data tracker. There's some data about hop-by-hop on internet paths, and there's some comments on what we think are the next steps. So first of all, the changes. Changes from 0.1 to 0.4. We rewrote quite a bit of things. We didn't change the overall goal, but we provided much more separation on the difference between hardware and software processing, trying to avoid this magic fast path, slow path term, which we think we now have done. We cited a 2015 survey in RFC 7872. We've also cited the IETF v6 ops hop by hop draft, which clearly is related to this whole subject of how do you get hop by hop options through the internet. And we added the security considerations text, which we had pending for a while, and think that now is ready for comment by anybody. It's now in the end of the draft in security considerations. And there were various improvements by editors and various people who commented on the list. Thank you ever so much for doing so. Please do read it. Please do comment. Anything more to add, Bob? Nope. Okay. Yeah. The intent here is to get the hop-by-hop options in the hop-by-hop extension headers deployable for people in the network so they are not filtered but actually passed in a way which will let the network evolve. To make that happen, we have to use some keywords like should and must. And it turns out that even people who've written lots of drafts in the past find it hard to balance the use of should and must when it comes to this particular draft. However, we've done this big rebalancing, and I think we are really at the stage where the text we will propose today actually matches something sensible. So read the draft, not this long list of should and must.
Well, let me interject 1 minute with my chair hat on. So the IETF requirement is everyone must wear a mask in the room unless you're speaking. So if you're not wearing a mask, please do. We have some up here. So, thank you.
Is that Dave Tyler?
Yep, I'm right here.
Dave, do you want us to talk a little bit further because this list is kind of awkward?
No, my only question is the wording up there literal, or is that a summary of what's in the document?
I think you should read the draft for the wording for the shoulds and musts because this is very context dependent. It appears very easy to say should and must, but when you're talking about a draft where, no, I'm not doing this. Can I take the question later, David?
Sure, I'll tell you what my question is, but I'm fine if you don't answer it or whatever, which is just some of the wordings in there is very vague, like low and reasonable. And those are things that one would normally never use in a statement with must or should because it's too ambiguous. Nobody knows what low is as to whether you can meet the should or not. Nobody knows what reasonable is. So would never use those in a should or a must. Thanks.
Low? Yeah, all right. Okay, comment on the use of low. Okay, got it. Understood, thanks, that helps. Next slide then. We had used an issue tracker. We kept careful tracking of the various things. We believe that when we came to process the last set of issues, that only 2 were left. And the first one is to try and get the should and musts balanced such that high-end routers might not support hop-by-hop options, and the text has to somehow balance this out with still expecting them to do so when they're looking at these options. And the use of fast path, slow path, fast and low and high and whatever else are still things that we have to get right, but I think they are words where we'll have precision, but they'll be hard to get exactly precise. We think both of these will be addressed in revision 04. So that's why I was encouraging people to read the draft. Okay, let's go for the next slide. Do you want to grab a go, Bob, for a second? I go, okay. So what are the key differences in the EH limits draft? There's a related draft. Everybody knows that hop-by-hop options are carried in an extension header. The extension header is one of a number of extension headers that can be present, and we now have an IETF 6-man work item on the extension header limits. Limits give more guidance on how to handle more than one options that a node can process. So clearly this is a slightly wider context than the hop-by-hop processing draft. Both drafts recommend using 00 bits in the option type to become the default. In other words, not to be under the misunderstanding that every router on the path is going to look at all the hop-by-hop options, and the first one who says, I don't like this, is going to give you an ICMP message. What's going to happen is really the processing that happens when you set 00 in the option type field, and therefore we are going to propose in our draft that every option type is treated as if it were 00 by default. Both drafts say that variable length options are difficult to process. This is true, and the EH limits draft is much more specific, and we could talk about those in the EH limits talk. There's differences on terminology, and we all know that fast, slow, full, low, high, forwarding rates, etc. are difficult to get right, and probably it's going to be important to find words we can at least live with for both drafts that were consistent. One of the things we were suggesting on the list was adding text about out of order of processing and the reasons you want to avoid having an option header causing a packet to be delivered out of order. We believe that's a very useful thing. We propose to add that text to our draft, copying this that's been already in the EH limits. So next slide. Right, so recommendations. Let's get to what we actually plan to do in the next edit cycle. The hop-by-hop processing draft, we think, should define the hop-by-hop processing element and should not look at the number of options in the hop-by-hop header. So EH limits draft should reference it. We should reference the document that we're editing, and we think they should cite the text but not define how the hop-by-hop options are processed. What we're trying to do is separate out the description of the hop-by-hop processing, which is done by nodes, from the wider EH recommendations. Some items we think should be brought into the hop-by-hop processing draft, discussing out of order packets and everything to do with nodes. Everything to do with processing along the path, not at the endpoint. The EH limits drafts should continue to define the total EH limits, and we don't propose to elaborate on that. So I think the right place to do is to provide comments to the document that Tom Herbert's editing to describe the extension header limits rather than discuss them in the hop-by-hop processing draft. So in this way, we're hoping to disentangle these a little bit and let the hop-by-hop processing work continue with the wider remit of how the extension headers should be processed in general and set up by the endpoints. Next slide, please. Other proposed changes are, well, I think I got there a little bit, but the purpose of this slide is to bring down that text at the end. This is the text that we have derived from that list discussion, which we would like to put into the next version. So nodes should process the hop-by-hop option header. If they do not, then a node must forward the packet normally. I hate the word normally, but it's probably a good choice to suggest that you go through all these little steps that you do when you forward a packet, because there are quite a lot of steps and we can't possibly enumerate them. But nodes must do that normally when the hop-by-hop option header is not processed, not dropped. When processing the hop-by-hop option header, nodes must process the first hop-by-hop option, and nodes may process more. And we weren't going to expand that and leave Tom Herbert to make more overall overarching discussions of how big an extension header you might like. So this was our proposed resolution of separating these two drafts and coming up with something which satisfies, we hope, the discussion on the list. Does anyone wish to comment on this because they think it's something useful to comment upon? Right, next slide then.
We have Ron Monica in the queue.
Oh yeah, good. I hear Ron's in the queue. Could somebody represent Ron?
Hello, Gloria.
Hello, Ron.
Oh, can you hear me?
Yeah.
We can hear
okay.
you. It's good to hear you.
Good to hear you too. Reading through your draft and Tom Herbert's draft, I read through them both, assumed that they would both become RFCs, and then said to myself, okay, if we had known all this stuff 5 years ago when we wrote 8200, the section on options and the section on the hop-by-hop extension header might be different. but it was a bit of a task to figure out how they might be different. Would it be a good idea to merge your draft and Tom's, and in that draft just put replacements for that section on options and the section on hop-by-hop extension headers? So the synthesis would be done by the authors as opposed by each individual reader.
Possibly. I think in the as Tom's been starting to formulate his extension headers ID, he's maybe created quite a lot of overlap, which we didn't imagine would be there. And part of the talk today is trying to pull those apart so that they are not too different documents talking about the same thing, but they talk about very specific topics. So I think you could have two documents that exist that talk about specifically just the hop-by-hop options and have everything that's normative about hop-by-hop options, and one that talks about extension header construction and handling. So I think these might be okay in separate documents, perhaps, because they probably have different readers. The extension header part probably mainly refers to people with NICs and end stacks and people who are implementing IPv6, as opposed to people who are doing routers or routers who maybe are more interested in the hop-by-hop processing. So I don't know if that answers your question, because I think clearly what you propose could also be done. So we could do what you say, or we could try and keep these two documents as two separate documents. Bob, do you have another comment on that one?
Yeah, I'm pretty much what you said. I think for now, I think they're better to be separate because I think we're approaching this in a different way, but they clearly need to be consistent and they need to refer to each other appropriately.
And I guess the second part of your question, if I understood it, was should we try and do normative changes to the 8200 by saying this block of text is updated by this block of text? Is that what you're asking, Ron? Okay. Other people in the room think Ron did ask that, so Ron can come back if he needs to.
Yeah, the extension header draft does talk about, has a section which talks about changes to 8200, so it's pretty close to that.
Okay.
Changing the block of 8200 once with the intent of both drafts would put the task of synthesis on the authors, as opposed to having each reader synthesize the two and figure out what 8200 would look like had we known all this stuff 5 years ago. I'd also like to comment that there are some folks like PLMs from router companies who need to read and implement both. So it makes life a lot easier for the reader.
Understood. We will think about this. Suresh.
Yeah, thank you. Thanks, Corey. So one of the things you threw up was like the first option, you need to look at it, right? So I just want to point out, like, nothing against or for it, right? But it's a certain change in how we treat hop-by-hop options, because they were never treated as ordered. And I know, like, we talked about this quite a bit in Connex, right? Like, we are throwing this as the first option. There's no special thing for first option, right? So I think I just want us to be cognizant that we are actually making this change, that, like, first option is somehow special. And the second order effect is, like, there's going to be options that are going to be jockeying to be the first option, right? I just want to make sure that it's noted somewhere, because, like, I think this becomes like a privileged place for an option to be. So I just wanted to note it somewhere.
Yeah, and I think that's fair enough. I think also that means that putting the option on every packet may not be something that you should now do, because that means you've kind of trumped everyone else.
Exactly. There is, like, some text in the Connex v6 option draft, like Miriam and I did. Like, so maybe we can try to, at least in an older version, so I can actually try to dig up something to give to you, right? Because that is really a worrisome thing. Thanks.
That would be really useful. Thank you.
Okay, Zhen Bin from Huawei. I want to add this additional information. In fact, when we deploy the IPv6 enhanced innovations, such as SRv6 and IPv6 based network slicing in the existing network, so that we also encounter these issues about the process of this hop by hop header and destination option header, and also the processing these options in these headers. So in order to solve these issues, we propose the one draft that is to use these protocol extensions to advertise this information about the capability of the forwarding plane to process this IPv6 extension header and options. So later I will send this one for the comments. I also would like to align this draft with this some of this capability and these procedures of this draft. Okay. Yeah.
Please do send it to the list, yeah, and we will discuss this.
Okay.
That'll be useful. Yeah, next slide.
Go on.
And next slide. So this is a 2-slide picture from an IEPG talk, which is in the proceedings. So it's done by Anna Aberdeen, and basically it's doing an exploration of which packets might get through the internet if they had extension headers applied to them. Is there a limit on size? Because people talked about the size of packets mattering, and we have traversal rates for extension headers of different sizes, and we have hop by hop in black and destination options in blue. And you can see the traversal rate for destination options on the tests we did across the internet. If you want more, look at the IEPG talk. This is just a teaser where there's a lot more data from Anna and other people. But basically, destination options get through a lot more than hop by hop options. Not surprising. Hop by hop options do get through. There's a difference between TCP and UDP. If you want to tell us why, that would be fun. Not necessarily at the mic, but do catch up with us and tell us what you think about the data. But basically, extension headers with hop by hop options, which come to a 40-byte extension header, appear to get through just as well as any other size. So we can easily think that one header will get through reasonably. If you're going to formulate a big header chain, then the probability of successful transmission reduces. Why 40 bytes? I don't know. If you make routers or firewalls or whatever and know where this number comes from, tell us. It happens to be the same size as an IPv4 option header, so maybe people think that's okay, or part of an ATM cell or whatever, I don't know. But 40 bytes is okay. So everything we've said in our draft appears to be good for this. Next slide then. Then the question is, where on the path do things get dropped? And a lot of the packets that carry extension headers get dropped pretty quickly as they're sent from a home or ISP network. As they get to the first AS, most of the drops that occur will actually have occurred maybe on the first hop, second hop. So the packets don't make very far into the internet when they don't go. So those packets that are dropped very quickly, probably by policies, I would imagine, which is probably the reason why we're writing this draft to say, please don't have this policy. Much more data in the big talk. I'm conscious of time, but Nalini is asking a question and is definitely the right person to ask a question. If you can reach the mic.
That's right. That's right. Hi, Nalini Elkins. I'll keep this really short. But our while I understand we're not the protocol police, it seems to me from our testing, there's a handful of organizations in particular, if they would change some of their behavior, we might see, the 80-20, we might see a great deal of improvement. So thank you for all your testing.
And that's why we had a talk at IEPG that you might want to look at, particularly if you run IPv6 networks, which you should. Next slide, please. These are things we learned. Some paths do support hop by hop options. The game's not over. there's a chance of using this. You have to choose a path, try it, and see if it works. Many currently drop packets with a hop extension header, and that happens very early, and some people are much more prevalent at doing this than others. Limiting the size of extension header did improve traversal, so expecting one hop-by-hop option to get through is much better than just saying an arbitrary number, as we did in the original IPv6 spec. So we think the recommendations we've made in the hop-by-hop processing draft would seem to help. And final slide. We have always to get the language right. We think the current draft's much better. We're about to push a new version. There's work to align this with the EH limit draft. Whichever way we go, we have to get the language correct. We have to get the dependency correct. We believe the dependency could follow what we've outlined in this talk, and we'll listen to Tom's talk afterwards and then discuss with him. We think this could go to working group last call soon. I am personally, as one of the editors, not sure that we need to wait for the EH limits draft to complete before this is working group last called. I think we can, with a reasonably high probability, separate the two and complete this first item. Of course, if we go for Ron's combined item, then we wait for them both to complete at the same time. So I'm hoping to go for working group last call, probably in one IETF cycle if we can. And that's my presentation.
Thanks, Gory. I guess, yeah, we can discuss last call situation after because we just slightly running late. Okay, so Tom.
Yes, can you hear me?
Yes, we do. I'm sharing the slides. Just a second.
Okay.
Got it.
Good.
Go ahead.
Can you see them?
Yes. So my name's Tom Herbert, and I'm going to talk about the other draft, about extension headers. Next slide, please. So status, it is a working group item. There's been some list discussion, mostly inspired by Brian Carpenter. I'll touch a little bit about that. Similar to the hop-by-hop processing, we think this is ready to go to working group last call soon. Would like to see more activity on the list, so please read and provide feedback. Next slide. So we have version 1. The changes were relatively minor. There was one change in the padding. Previously it said no more than 8 bytes, but really the maximum amount of padding should be 7 bytes. That guarantees that we can align any option to 8-byte alignment. We need to correctly reference RC8504 instead of RC8200. The default limits at intermediate destination for processing options is 16. So 16 is based on pretty much all the nodes where we wanted on receive, we need to have a default limit to how many options they really should process. And the 16 is actually both the padding and non-padding options. And other than that, there were a number of edits in the document. Next slide, please. So I did the comparison with hop-by-hop processing. Gory went over a lot of this, so I'll maybe give the perspective from the EH limits draft. So first of all, I think the focus is different. And for that reason, I do agree that these should be separate drafts. The hop-by-hop processing really is about processing the hop-by-hop options. And that seems to be guidance directed towards implementers or routing vendors. In the EH limits, it really is about requirements. We want to provide specific numbers, specific limits. Most of the draft is actually that. It's very specific requirements. It goes down into some of the details of extension header processing, in particular for hop-by-hop options and destination options. It enumerates all the limits about padding, number of options, the possibility to set length per option. So it's very much on the side of what are the limits. What we don't do in the H limits draft, though, for instance, is discuss the fast path, slow path split or any guidance around actually implementing this. Also, I think there's less of a we distinguish less between high performance routers and other devices. What we do distinguish, though, is there's a requirement specific to end devices, host devices, by sending and receiving extension headers, as well as intermediate devices, how they process that. And also for destination options, we have a concept of intermediate destinations. So the requirements are based on the role in the network, not necessarily the performance or the goals of the role. So I think the requirement there is, from our side, is keep them as separate documents. I do think that the limits are important, such that the hop-by-hop options could reference the EH limits document. So the second difference, as Corey talked about, nodes must process the first hop-by-hop option in HBH processing. It looks like that's going to be relaxed a little bit. But the difference here is in EH limits, the first option really isn't special. The idea is that a device can set a limit how many options are processed. And these options that are processed must be in order starting from the first one. So for instance, the default that we recommend is intermediate nodes should process up to 8 hop-by-hop options non-padding, which means when they receive a packet, if they process hop-by-hop options, they should, by default, try to process the first 8. But they can process any number between 0 and n. So 0 is the RFC 8200 guidance that allows that. N would be some number of contiguous hop-by-hop options, padding and non-padding. And that would apply to both hop-by-hop and destination options. So then once we decide that we only process part of the options or some of the options and not the full options, the question becomes what becomes of the rest of the options. So hop-by-hop ops processing says that a node may process the first one and skip the rest. And EH limits, I think we're a little more specific. The node can process the first n padding and non-padding options, or the first n non-padding at least. And then for the rest, they're ignored beyond that limit. But that is only at intermediate destinations. At the final destination, the behavior is a little bit different. The destination host, and I believe this is consistent with RFC 8504, can process the first n options as a limit. But if there's options beyond the limit, the host must drop the packet. The rationale there is, unless the host processes the full list of extension of options, it wouldn't know if that's a malformed packet. So the host does have to process all of the options. What this means is, in practicality, is that even hosts are going to have limits. For instance, we can't process hundreds and hundreds of options in a single packet efficiently. No one can do that. That'll also be the only use case has a denial of service attack. So we think that the host does need this requirement and does need to drop when the limits are exceeded. Next slide, please. Some other differences in hop-by-hop processing. Source node should include a default single hop-by-hop option. So when sending, the idea is that the default in hop-by-hop processing seems to be send one and maybe more. In EH limits, we describe that a little bit differently. We recommend sending up to 8 non-padding options as the default. The rationale here is that whether or not 1 or 0 is sent is a bigger difference than sending more than one, especially if we allow intermediate nodes to ignore options past the first one, that means that the only thing special about the first option really is the fact that it's the most likely to be processed. But in environments where the source knows that the path can handle more than one option, or has a need to process more than one option, there's really no need to limit it from the sender, with the assumption that intermediate nodes don't care. Obviously, when we start talking about the limits of the header chain, this would be relevant, but that's actually a separate topic, how many bytes you can have. So I think the requirement here is assume the EH limits. We don't necessarily want to try to limit things to one option, even as a recommendation. I'm worried that that's going to be an extensibility issue. And besides that, operating systems really aren't designed to enforce this sort of limit anyway. The last major difference is around the area of how big extension header chains can be. Hop-by-hop options gives this guidance, hop-by-hop options should not be a variable size that can extend beyond what can be executed in a fast path. EH limits is more specific. The current limit that we're proposing is 64 bytes maximum of extension headers. The whole IPv6 header chain fits in 128 bytes. As I said on the chat, that's a little bit inconsistent with this data that shows 48 bytes are commonly able to be transmitted. So I think that's an interesting question, why 48 bytes? But the rationale here was devices should be able to parse with a parsing buffer of 128 bytes, and that would fit an Ethernet header, IPv6 header, and the first 8 bytes of transport header plus 64 bytes of Ether extension header. Sorry. So I think we do need this. The requirements probably are appropriate in EH limits, but obviously there's maybe some discussion on what the actual number is. Next slide, please. So that's all I have for today. Thank you.
So we should, two people in the queue.
Yeah, we have 2 people in the queue, and after that we close the queue because we slightly run out of time. Gori.
Okay, if we're short of time, I think we could take this to the list, but clearly, Tom, it would be good to work with you to get a coherent set of recommendations for both drafts.
Yep, let's do that.
Hi, Tom. This is Tim Winters, QA Cafe. So 8504 has text. Are you planning on updating that text? Is this draft going to be an update of that, or is it essentially the same? I'm going to read it and diff the two, but that was my other question here, is if you were actually trying to update general node requirements, or what do you wanted to do about that?
I think it does update 8504. So we'll need to make that, put that label on the draft.
Okay, thank you, Tom. Suresh?
Thank you.
Oh, thank you. Go ahead. Thanks. Next slide. Thank you. So the draft completed last call in 6-man. So I think it's not officially closed yet, right, Jen? So there is some comments like pending from spring, and I have a slide to talk about it. But thanks to everybody who commented. Like, I was actually pleasantly surprised how much we got. Like, especially Adrian, thanks for your review. Like, that was like amazing. There's quite a bit of stuff, and a lot of it has been around tightening the language. So like so I was using like language for routing and forwarding kind of interchangeably, and that could be read from somebody from the routing area differently than how we would read it in 6-man. So I think like Adrian kind of helped quite a bit in tightening the language around it. So that's been done. So like pretty much all the comments received during the last call have been addressed. There's like one specific one I had to call out, like Edward Metz. It came like a week after last call, but I think it's still worth addressing, but I didn't want to do it like one day before the submission deadline to just rush something. But there's something I should like address after the IETF completes, right? And the key thing to, sorry, It's okay, I can just talk through, Jen, don't worry. So the key thing is like to talk about the prefix that's getting allocated, to say it's gonna be optional, okay? I think people are trying to read my lips, so I'll just go. So the key thing is this use of this prefix is optional. So nobody's gonna be forced to use this prefix. And so that is, I thought it was always understood from the draft that it's like allocating a prefix for use for somebody. But people had like specific questions saying, hey, should we use this for SR all the time, right? So that is not the intent. So I'll add in text in there saying this is use of this is optional. So that's going to come in, but I'll circulate the text on the list before adding anything like that. But the point is, right, by allocating this prefix, like nobody's going to go ask for a prefix just for doing SR. I think that is the goal of doing this. And couple of days back, just before the IETF, I got a mail from IANA along with the chairs and the AD. So this is awesome, right? Like this is like an amazing process that IANA is actually doing early reviews of drafts for IANA things. And I was like really pleasantly surprised. So thanks, Amanda, if you're like, you know, looking at it. So I just put together a straw man proposal for how the prefix is going to look in the special purpose registry. And if you look at it, it's very similar to what ULA does. Okay, so it's a forwardable prefix, so it means it can actually cross a router, because as long as you're in a domain, the router should be able to forward it. So it's not like link local. So that is really what the forwardable thing means. And the globally routable is false, because there has been actually some proposals during working group last call, which said like, oh, we should like make it centrally registered and be allowed routing. But I don't think we started off with that intent. Okay, so if somebody wants to discuss that, that's fine. But I don't think that was what this draft got out to do. Okay, so this was like for somebody to use it on a best case basis inside a domain. So we don't really want to have a registry or like make something that's like globally unique going forward on this. So my strawman proposal again is like globally routable is going to stay false. And the protocol field is false as well. I think it should be like one thing down, but moving to PDF got rid of it. But the protocol field is false, because if the protocol field is true, then all IP compliant implementations should support this behavior. So which is something we don't want. So like it's going to be false in there. So this is the proposal. Of course, it's going to go on the list as like a discussion point as soon as like Spring completes their review of the issue list, right? That's in the draft. Next slide, Jen. Okay, so so I'm going to put in this like new text. I'll circulate the text for adding this prefix use optional thing, just to make sure that it's clear to everybody and I don't miss anything obvious in there. And again, thanks everybody for like commenting during working group last call. It's like, I think we got like 15 or 20 comments. Like it's amazing for like a short draft like this. And wait for the Spring conclusion to move the issue list from here into the CSET draft. Like we can take it out of here, but Spring has to pick it up because we don't want it to get lost in the cracks somehow. And I think Jen has already sent a reminder to the Spring chairs to kind of close this, right? And so the comments that are actually received, I think like Dhruv sent something. There's like 2 or 3 people who commented from Spring on this, who said like it's fine to move the issue list, but as long as there's an official conclusion from Spring chairs. I see Joel back there. So if Spring concludes that the issue list is fine to move over, then I think we can close that part of it on the draft. So Joel, did I surprise you? Exactly, yeah. So as long as it's done, then we can just like close this draft. So open for questions.
But to clarify, so we're basically waiting for Spring to decide what to do here on that. We're waiting for the Spring working group to decide what to do.
Yeah, so there's like section 4.1 in the draft, right? It says like the Spring needs to do these things. Yeah. So that needs to just move over before we close the draft. Lorenzo, were you going to say something? Okay. Okay. So if there's no comments, thank you very much.
Thank you.
Thanks.
Thank you. So, Janbin. Okay.
Share. Good. We're back on time.
Yeah.
Okay, Zhenbin and Huawei. Today I will do the presentation about carrying VTN information in IPv6 extension header. So this is regarding the network slicing, or this is called the network resource partition in the TIS working group. Okay, next slide. Okay, so here this is the background. So in fact, in this draft, it's introduced a new IPv6 hop-by-hop option to carry this network resource partition information in IPv6 packet, so that this can used by network nodes to identify the VTN the packet belong to and forwarding the packet based on the resource indicated by the VTN identifier. So the VTN option can be used to IETF network slices and maybe could also be used in other scenarios. So this topic has been proposed in the past IETF meetings so that they think about how to generalize this VTN option. So this draft, this presentation, we will focus on this topic. So next slide. Next, yeah. Okay, in fact, in the TIS working group, we propose one draft is discussed about this, the possible generalization use cases about the IETF network slicing. So that from our point of view, in the existing IPv6 VTN options, because we have the flag, we also have this VTN resource identifier. We can use a different flag and can generalize the VTN resource identifier for different purposes. So that means existing the mechanism of this option can support the generalization. But the most important thing is what's the use case and how what identifier can be generalized use this existing VTN resource identifier. So this draft in the TIS working group, we talk about the possible use cases can be generalized based on this the VTN resource identifier. It including the possible that use to indicate the topology. It use to indicate the resource, not only for the bandwidth isolation, but also for the some other service functions such as security or the network management. And also, you know that network slicing, we have the different topology. Maybe that's the multiple MP to MP topology. It also can be the P2P topology. If it's the P2P topology, so that they can think about if this resource identifier can be used as some identifier for the P2P path. So this is just some use cases as identified in the TIS working group's draft. So
We're having a technical problem.
okay. Okay, I have to wait. Okay.
This one?
Okay, so this, okay, so this next. Next slide. I think they finished. Okay, so here this is just some this talk about this thinking on the generalization of the VTN semantics. So we think that this network, we think that the identifier of this the VTN resource, it should be associated with a set of network-wide attributes. That means we emphasize that is network-wide instead of the specific node or the path, specific path identifier. That is here. That means this should be the network-wide attribute instead of the path-wide or the node-wide. So that's the first want to, if we want to do the generalization, we first to identify this one. So this is the first one. Second one, so that we think what this network attribute can be identified. So we think that currently that is the first that's related with original network slicing. We think the link bandwidth, and also with some this is the bufferage or this queue that's used to guarantee the SLA for the network slicing. So I think this is original meaning. I mean, so this also here there's some the generalization. It's not only the bandwidth, but maybe other resource to guarantee the SLA. The second one, we think the network attribute, that is the topology attribute, because this topology that is network wide. So here we identify the possible network topology and the P2P, P2MP, and MP2P or the MP2MP. That is identify the different this topology attribute. The third one, we think that we also have the network attribute for other, for the resource for other service function. So this we think we may also can use this resource identifier to identify the resource for other service purpose, such as security or network management. So I think that's we think this important to identify the boundary of the generalization. We think this maybe is too hard just to set that is just a generalized identifier. It can be everything. It can be anything in the future. So we think that we can generalize, but we also use this use cases to identify the scope of this generalization of the waiting resource identifier. So next one. Next.
So we have a person, thank you, Eric.
Yeah, Eric Ving, so no hat and hello, Zemin. I just wonder why we keep getting this stuck to 32 bits ID. It would be, we have reserve bits, so we could put the length there and generalize this to many, many other use cases.
Yeah, in fact, this first one, I think I have explained this the purpose about the generalization. I think in IETF, when we do some this the protocol specification, it should be firstly identified by the use cases. So I think for the generalization, I think that we must to identify what's the use cases and what's the identifier can be generalized. This is the first point. The second point, I think in the existing the waiting options, it also remaining the capability for the future extension, because we have the reserve the flags. If we use a different flag, so that the flag so that indicates the different meaning of the waiting resource identifier. So I think even in the future, if some use cases still want to reuse this option, I think that we need not to change this option type, and also is just to use some this new flag for the generalization. So this is a second point. Okay. Yeah. Okay. So here, so this I just to mention this one. So this draft, we also have some related draft. The first draft, this is the 6MAN, that's a topology ID draft. That means use identifier to indicate the topology. So that means the topology is also a resource. According to the description in the previous pages, so we think that maybe this topology ID can directly use the waiting resource identifier, because the waiting resource not only include the resource attribute, but also indicate the topology attribute for the network slicing. So from our point of view, so that the waiting resource identifier can directly use as a topology identifier. Okay, but we think that the question is that because if this can be used as a topology identifier, so that means that existing the features, the multi-topology or the flex angles, this may be also that is created before network slicing. In fact, they can independent from the network slicing, but now because this identifier can reuse the waiting resource identifier, so that means this multi-topology must be used combining with network slicing. This is can be accepted or not. We will ask for the comments in the TIS working group and the IGP working group. If they agree with this one, so I think this this waiting resource identifier can be generalized to indicate the topology ID. This is the first one. Second one, I think this is a path identifier. In fact, in the Spring working group, there's the one draft is related to the path segment. That means use the path segment to identify the SR path. So that is just use some this is the path identifier. But I mentioned that the P2P slice because it's just is point to point. In fact, so that's the waiting resource identifier can be used as this is the path ID because it's just the point to point one. But from our point of view, we think this is just a special case of the network slicing. We think we should not use the waiting resource identifier become a path identifier. So in our opinion, we think the waiting resource identifier should be the network identifier. That means only to indicate the network-wide attribute, instead of the path attribute. So that means if we need some this the information regarding the path, we need to introduce an independent path identifier. In fact, instead of reusing the waiting resource identifier. So this is
we're out of time. So you're going to
okay.
wrap up.
Yes, done. Okay. And the last one, I think this we also have the multiple this waiting resource identifier. That means we have the global for the cross multiple domain and also the local domain. That means we have the the different resource identifier. We think this we must use the independent identifier for the different scope. So this is just a third one. Okay, next page. I try to finish. Okay, it's almost done. Okay, so I think we can go to the next one. Okay, so I think this is just the major thinking about the generalization of this waiting resource options and the waiting resource identifier. So I also that's thing explain the design thought about the generalization and also identify what resource identifier can be generalized with this one. So I wish you can review this draft and also think this use case does make sense or not. If it's okay, so that we just make this as a strong base firstly. So then later we will use other draft to define the generalization. That's my other presentation. Okay, thanks.
Okay.
Okay. Okay.
No.
Okay. Thanks.
Okay, no questions. Okay. This assumes I have another USB-C. Okay. Next. I guess next is Justin, right?
Yes.
Okay.
Do you want the cable back?
No, because I need to.
Well, can you charge enough?
Yes. Sure. Okay. Yeah, let's go. I'll just. Yeah.
Hi, Justin Yerman, Julius. So this draft is actually about carrying a generic identifier and IPv6 packet, and this is actually really close and related to the previous presentation. Next slide, please. So actually, the idea came to mind right after previous meeting in Philly, because obviously we had two drafts with kind of similar use cases. And by similar use cases, I mean they were trying to, carry a 32-bit identifier. And the problem is that they wanted to allocate a new code point, both. So you had to create 2 code points for similar use cases, right? And there were some concerns, and actually there are still concerns, it looks like, actually. So the problem is that it's not generic enough, right? So why the second draft on the list here has expired? The first one, which has been presented right before this one, has evolved to make it more generic, but I think it's more generic still in that VTN context, right? So the question is, should we do something about that? And if we choose to do something, well, there might be several solutions. So the first one obviously is to have, a generic container for an ID, and here the data length of the option will be the length of the ID, so in octets, right? But the cons here is that it may be too generic, right? And besides, you have no context, which means you don't know actually what you are receiving here. So an alternative to that is to have a new registry. So the field name is context type. Thanks to that field, you would be able to know which type of ID you are carrying. And actually with that registry, you would be able to control what is defined in that registry, right? Thanks to that, you would be able to have a kind of structure in the data, not only an ID, but maybe several IDs, but also flags or whatever. So if I take your draft, I know that with the new revision, you have flags, for instance, in your structure. So it would be possible. But again, a cons here would be that you have a sub-registry. So I don't think it's going the right way, Gory left, but I think for the efficient processing of by hubs, it may not be the best idea, but anyway, you have always trade-off here. So I'm open to a good discussion here. If we do something, should we have both solutions, either, or should we do nothing and have none?
Yeah, it would be good to get feedback from the working group on this, because something like this would allow a way of carrying a lot of identification information without having to do a whole new type for each one. There could be a registry where it would be, I think, an easier process to get new things done, but it's like with all things has trade-offs. So comments are appreciated.
Hi, Jidong from Huawei. Yeah. Actually, as you just see the previous presentation, with the flags field and the reserve field, there's a similar capability to generalize this option, the VTN option, as what you propose in the second option. And I fully agree that for the similar functionalities, one option will be good enough instead of two, right? And regarding the VTN concept, I think, as Robin just mentioned in his presentation, I consider as a network-wide generic concept, and can cover a set of network-wide attributes which can be applied to not only network slicing, but also other generic scenarios. So my understanding is maybe we can just follow the existing option to make it generic. But before that, we can have a base version to meet the current requirements first. So, okay, thank you.
Okay. Well, let's let the mic finish.
Michael Richardson. I guess my first question really is to do with or is a question to people who have knowledge of configurable hardware that is going to be able to do this is, well, can you match this? Can you match this intelligently? Or are you limited to looking at the option type there? So I think that's a really big question. And I mean, you can imagine new things can do whatever, and P4 people can, do whatever they want. But I think the question is, going back, what is easiest? The other part of that question, I think, is based on what I think Gory said at the beginning, was that going forward, we're considering all types as if they have 00 at the beginning. And if that's literally true, then we have, in effect, 4 times more option fields, option types going forward. And maybe we don't need to subtype it going forward. And so that also, I don't know if that's really in practice what he means, or that's where we're evolving to, or, we have 32 option types today available. I think we have about 9 or 10 of them in the registry. So we're not exhausted, but on the other hand, we're not super rich in them. So I suspect that we don't need a generic type, and that going forward we can reclaim those 00 bits for other things. But that's not to say that it wouldn't be good to have a document that said, these are all the considerations that options need to think about, and it makes life easier for the next guy that's trying to define a specific option. Sorry, that doesn't answer your question.
Yeah, sure.
Right.
Zhenmin from Huawei. In fact, I explained some of this design concept in my draft. So that's I also regarding this draft. These comments. The first one, the most important, is the scope of the generalization. This is very important for this one. The first, because if we use some of this context ID and we use some of the data, if we use this generalization, it can be everything. This is not only the VTIN or this topology, it can maybe also cover the information of other IPv6 options. Even for example, the MTU option, you can also use this the data structure to indicate. I think this definitely does not work. This is the first point. The second point, this boundary. If you use this one to identify, so that's this is the scope. That means the data must be identifier or can be other things. That means this must because this must be defined. This is the identifier. This is the if this is or not, this must be defined. The third one, if this is identifier, generalized identifier, so that is also the use cases I mentioned, because this can be any identifiers, but maybe this identifier can be defined by other draft and also by other options, and they maybe have these identifiers maybe do not have this common attribute or this common meaning. So this is just why I think if we want to define the generalization, we must take use of the use case driven method. That's my point.
All right.
Pascal Tuber, Cisco. Just a reminder that for REPL, we have defined one option, which is a hop-by-hop option that signals a topology. REPL is designed to route over multiple topologies. And this looks like a similar situation as the VTN. So I was just wondering, instead of allocating new code points, if we could extend the code point that we already have. So we have less discussion about how many we have, rather than keeping this one completely specific to REPL.
Okay. Thank you, Justin. Paulo?
Hello, Paolo Volpato, Huawei. I'm presenting on behalf of Edward, my co-author, that should be connected online. And this is about the status of the draft you see here. So the usage of neighbor discovery protocol to support multi-homing, multi-prefix. So next slide, please. Quickly, the scope, it was presented at IETF115, Philadelphia. It's about, discussing the usage of multi-homing, multi-prefix, which is a solution that has several, it's a mechanism that has several solutions. We have tried to look at the open issues, just focusing on neighbor discovery protocols. So you see there the references to the RFCs, the 4861, 62, and the default address selection, 6724. What we have proposed, probably you remember the discussion at the last meeting, is something that apparently could be, let's say, criticized because it changes, it swaps the two steps defined by 6724. So instead of selecting first the next hop router, we look first at the source address. So that's about the draft. Next slide, please, Jenny. So what we did in the past months, there was a request from the chairs to refine the problem statement. So we have reviewed the introductory section of the draft. And at the IETF114, we received also some feedback about the content of the draft. So we included also a kind of high-level analysis on provisioning domains, and that brought to the, let's say, review of a couple of sections of our draft. So section number 3, which is about the neighbor discovery protocol analysis for MHMP, and section number 5. Then we also received a comment about avoiding overlapping with other ongoing drafts. Maybe that was related to another draft that we posted some time ago. I guess not specifically to this one, but anyway, it was the right chance of giving a kind of general revision to the document. So we hope we have done a general cleaning. Now, specifically on provisioning domains, and we can move to the next slides, please. As I said, we just did a first analysis, very high level. So we don't pretend it's complete. And we are really open to feedback and suggestion from the working group. We tend to think that there are still a few open aspects. We're not completely sure about that, but probably, let's say, the issue is related on the usage of the APIs on a host or on a server, let's say, how they are used by the application. So we have probably a couple of use cases we would like to share with the community just to have feedback. So our question is, if there is interest in doing so, we would like to share through the mailing list or any types of offline discussions what we have found so far. One possibility, as I said, could be related to the usage of the APIs. Probably if you would use the bind, which is probably something on the server side, we would say no problem at all. So any type of solution works, and provisioning domains is more than fine. On the host side, probably there could be something open due to the usage of get other info. But here we are not completely experts, so we like to hear from the community. Anyway, we're open to the discussion. If there is interest, we can move on and share what we have found so far. Next slide, please. So next step, as I said, provisioning domains is something we would like to discuss. So if there is interest, just get in touch and we can share what we have found. And again, if there is any feedback or a proposal to extend the scope or even criticism, we are more than open to accept that, and also co-authoring is welcome. And that's it so far. Thank you.
Okay, good. Thank you.
Journey.
Is it a comment? Yep.
Jen, are we taking questions or you're short of time?
No, go ahead.
Okay, Suresh Krishnan. So have you followed the work in Interia that Eric was working on before? And I think the scope of that, like, okay, there was a MIF working group that was like a lot of work that was there. And the idea was to shorten the thing to minimum thing required, right? So if you want, you have a hard time hearing me. So I think one of the things was actually to scope it down, right? Like to the most useful use cases. So if you want to expand the scope, probably like, try to go to Interia, have like a talk there, at least to people who are done the work before on the provisioning domain, and to kind of see like, if there's going to be adoption on the end host side. Because like one of the things that MIF kind of didn't succeed in was like the end host like had to have a much smaller subset of things to do, right? And so I really suggest you go talk to like, like Lorenzo, who's sitting here, like, or like somebody who's on the end host side, like Stuart, who's in the IETF2, to go and see like if this is an issue they are facing as well before you embark on more work. That's my suggestion. Thanks.
For sure. Thank you for the suggestion. As I said, the idea is not to extend the scope of this draft. We really want to focus just on what we are discussing there. But it's because we received, a feedback at the previous meeting. So we just want to be sure that we are not touching something that is already there. So we are not reinventing the wheel, basically. Thanks.
Lorenzo?
Lorenzo Colletti, just a couple of comments, I guess, just based on the slides, really. First of all, I think if you like selecting the address before you do the routing lookup, probably like doesn't allow you to implement like rule 1, which is to prefer like avoid unreachable destinations or something. So I think you kind of like can't build a straight line algorithm, I think. Maybe you've looked at this already. And for applications, for your other questions around should applications use, bind, or you pass the hint and get out info on the source address to use, I would not advise relying on applications to do that right. Like IPv6 source address selection is actually really hard. And one of the decisions that we made a long time ago in Android was to like not require them to do bind. They basically bind to a provisioning domain or a network, and then the stack figures out the source address. It's way too difficult because you have to figure out, basically you have to implement most of 6724 in the app, because you have to, prefer temporary addresses, like avoid deprecated addresses, all that's really hard. So yeah, happy to talk about this offline though.
Sure, thanks.
Okay, so I guess no more questions. Thank you, Paolo.
Thank you.
Okay, and next, Xiaomin, I guess remote, right?
Yes, I'm remote.
sorry.
Okay. No, I think.
Yeah, I see it. Hello, everyone. It's Tommy speaking. This presentation is on IPv6 query for enabled in-situ OEM capabilities. This is the third time I presented in 6-man. Next slide, please. This is the recap of this draft. This draft defines ICMPv6 extensions to achieve IOM capabilities discovery in IPv6 networks. This draft is a companion document of IBPM working group draft. This draft defines IPv6 node IOM information query mechanism. For this mechanism, 6 IOM capabilities objects are defined. Next slide, please. The corresponding IBPM document describes a generic format for IOM capabilities discovery that can be used in IPv6, MPLS, SFC, and VIR. This IBPM draft is currently in IESG evaluation. Next slide, please. The 00 version draft was presented at IETF112, and the 01 version draft was presented at IETF114. The latest version is 02. The main change in 02 version is that IPv6 node information messages defined in RFC 4620 are reused, and some extensions to those messages described. Next slide, please. This page shows the updated ICMPv6 format. In this format, new queue type and new codes are defined in this draft. Data field reuses what's defined in the companion IBPM document. Furthermore, the data field in IPv6 node information reply reuses ICMP extension structure defined in RFC 4884 to carry the IAM capabilities objects. Next slide, please. This is the format of IOM capabilities object. Actually, its format has no change in the 02 version. Put here just for completeness. Next slide, please. This page shows an example of IPv6 NI query and IPv6 NI reply. Next slide, please. There is an open question considering RFC 4620 is an experimental RFC. What category does this job belong to? Experimental, standards check, or others? The authors believe this question can be answered after working group adoption if this working group would like to adopt this job. Next slide, please. Yes, the authors ask for working group adoption of this job. Thank you. That's all.
Okay, thank you. Any comments on the mic? Queue is empty. So, Bob, I reckon we can run the call on the list. Okay, next, Edward. Share slides.
Okay, fine. Good afternoon, everybody. Do you hear me?
Yes, we do.
Okay, next slide, please. I will remind for start a little bit what is it about. We still have a security problem on the link because initially everybody believed that encryption will protect neighbor discovery protocol. Initially, it was IPsec, then SEND, but then it has been discovered that it's a challenge not just because of encryption. Encryption by itself is easy. It was a problem because for encryption, you need somehow to some trust authority, some trust anchor. You need to somehow to do key management, which is really a big problem for many enterprises, and for that reason, IPsec and has not become popular. It means that it's still possible to pretend to be man in the middle. It's still possible to hijack some communication on the link. If you are on the link, of course, you need to be on the link. But okay, it's potentially possible in some situations. It's still a problem. At the same time, we see that blockchain, Bitcoin, they have a good progress without trust to anybody, without trust to anchor. For that reason, it's possible to develop something like CJ Lite, something like simple version, which will connect IP address not to the public key or private key, as it was in SEND, for example, public-private key, but connected to the MAC address, which is, by the way, in many cases are already more or less protected, especially in wireless. In wireless, typically is encryption protected, and even for wired .1x is typically, in many cases, not always, of course, but in many cases implemented. Anyway, we are dependent on layer 2. If layer 2 will deliver packet not in proper destination, then it's anyway a problem. Please, next slide. I don't have intention to repeat the solution, but it's very simple. You need to collect all relevant information, hash it, hash and hash and hash again till you will get some number of leading zeros. And then if you have enough leading zeros, up to your security requirement, then some number of bits, for example, tail bits, 60 bits, could be used as an interface ID. Go next. It supports pretty much almost everything. It's compatible to temporary MAC or temporary IP address. Of course, for temporary MAC, if it's short-lived, then you need to regenerate it again, to do hash again, to find a new combination of MAC IP which you would like to use if you will change MAC or you would try to change IP. It's, of course, a little bit challenge, but it's not a big problem. It's compatible to almost everything except maybe one point. It does not protect against denial of service but by the way, encryption does not protect against denial of service too, because if somebody will try to make a lot of connections to you, then it will not help. What is really just one restriction, that because here only MAC to IP relationship is checked, it is not a check who is the router, because the router, everybody could claim I am the router, and it means that a guard filtering on some switch it's still needed. Therefore, it's not a replacement for a guard. Next slide, please. What has changed since last time? There were a few comments primarily on the last IETF and one comment on the alias. And to reflect what has been asked in the comments, the text has been changed a little bit. It has been discussed that typically layer 2 is already protected by encryption. It has been discussed what will happen if would be duplicate MAC address on the link. Somebody will try to be duplicated. It's probably will create flapping and no one will work anyway. It has been discussed what that MAC change is the same complexity as IP change. It means no, it's more or less easy, and some small other comments. It looks like from not very big feedback from IETF or alias, it looks like the problem is not so much interested. Okay, but it's still a security problem for which we have savvy development, which is deep filtering on switches. We have initially send, and we have after this HBA, and we have many things before in the past when we were trying to protect link layer, and it's still not protected. For that reason, it looks like important topic, but from not much interest yet. Therefore, I will be happy if anybody will join this particular draft, especially on blockchain side, because maybe my understanding of blockchain is not the best. And if you will look to the draft, you will see that it's a lot about blockchain. It's a lot about the proper calculation, the challenge, the proper calculation of parameters which needed for blockchain to work properly. For that reason, especially if somebody is good on blockchain and will join me, I will be happy. But anyway, any feedback is welcome. That's it.
Okay, comments, suggestions, silence.
Thank you.
Okay, yes, I guess we continue discussion on the list. Thank you, Pascal.
Hello, I'm Pascal Thibert from Cisco. Next slide, please. Okay, so just attracting your attention that for some subject in this group, there is over the years, there's a lot of work which has happened, for instance, in how we configure an interface ID. There are all those RFCs which impact all those other RFCs. So it means that sometimes we spend a lot of time on some primes. Next slide. On the other hand, on some other primes, we have not spent so much time and energy, and we are still living on assumptions that we inherited from the times of IPv4. And in particular, what subnet is, what an IP link is, are still concepts that we've built more than 20 years ago. And we're still living with this mind image without really specifying what it is. Next slide. Now, for the last 15 years, there were groups in the IETF which have been working on how you do IPv6 over radios. And this includes MANA, this includes ROLL, this includes 6LoWPAN, 6Low, number of working groups. And those working groups using wireless discovered that the traditional model that we had in mind did not fit the reality of the networks you could build with radios. So this raised a number of questions. And we realized that the model where the link, the broadcast domain, the layer 2 link, I mean, and the broadcast domain have to be congruent with the subnet and the IP link could not survive over wireless links. And we also realized that there was a lot of power actually not trying to maintain them congruent. And we found that the old view of looking at what a link is or what a subnet is was actually damaging to power, to spectrum efficiency, and now that we care for it, for energy utilization in general. Next slide, please. So if we look in more detail, what all those groups converge to is that the link that IP needs for wireless is not a complex structure with many nodes on them. We ended up building IP links which were always point-to-point. And if you think about, for a second, about what a link local address is on a radio, what that should be and how you would do that. I mean, you take your radio with you and you go across the world. When do you do that? How long can you expect that your address is unique? So what is this link on which you configure your link local address and for which you can expect it's going to stay unique? And we ended up figuring out that the link has to be a handshake, an agreement between two nodes. And within that agreement between two nodes, then your link local can be confirmed as being unique. And so that's why we built the IP links, regardless of what the broadcast domain is. And on radio, the broadcast domain can be a lot of stuff. But we still consider always that a link, an IPv6 link, is a pair of guys that agree that they will use this pair of link local addresses to converse. It might be that on my radio interface, I build more than one link. So my interface and my links are not the same thing. I can have multiple IP links with multiple peers. And it might be that I cannot form a single link local which will be unique for all those peers. It doesn't matter. For each of those peers, I can build a different link local address. Oh, by the way, there is typo, which is usually reflexive and often asymmetrical, is the radio link, not the IPv6 link, obviously. And same thing for transitive. Next slide, please. And the same discussion happened for what is a subnet. Used to be that your subnet was your broadcast domain. So I have this switch fabric, I run spanning tree or L2R, and I can basically broadcast to a certain number of nodes, and my subnet will be this set of nodes or maybe a subset of this set of nodes. So it will be contained within the broadcast domain. And then again, this is redamaging. When we want to build a radio network, and we do, we can build networks which spans over kilometers and have thousands of nodes, and we do build those networks. They have thousands of nodes in them, and certainly they are not contained within a single broadcast domain. So we basically build three sorts of topologies on which we can apply a subnet. The simplest is the same as your IP link, so it's going to be a pair of nodes, and let's decide that we have this prefix, and let's form this prefix over this subnet. Or if you look at a network like Bluetooth Low Energy, for instance, then it makes sense to define that a coordinator is a hub and provides the prefix. And then all the devices attached to this coordinator will build autoconf or whatever, an address from the prefix of that hub. So you build a hub and spoke, and the router is typically the hub. And now, when building larger fabrics, larger networks, we build what we, so-called mesh. And with Ripple, it's a route over mesh. We route over this mesh. And you see the links are, again, point-to-point connection between devices. And the subnet is more or less administratively decided. All the nodes which form addresses from the same mesh prefix and participate to the same routing inside that mesh will belong to the same prefix. And this allows to administratively decide the size of your subnet, what the subnet will be, etc. So you gain a full freedom of deploying your subnet over any topology, including overlays. Next slide. So to build this IPv6 ND as was built 25 years ago, has a number of, I would say, unmet expectation. The first full unmet expectation is that ND was defined for a network where a broadcast was cheap and reliable. And we know that even though, for instance, 2.11 with the BSS can emulate a broadcast, it's neither reliable nor cheap. Then the other expectation is that the links are transitive. If A can see B and B can see C, then A can see C. And when you build a radio mesh, clearly at some point your broadcast domain, what your radio can reach, cannot get to any far devices for which you need to relay. So this is why when we build MANA or IoT networks, we relay at layer 3, we route. This allows us to save a lot of energy because we don't rely on broadcast anymore. And that also allows us to administratively define what the subnet will be. So we gain a full freedom of defining what IPv6 will see, regardless of what IPv2 layer 2 gives us. Now, there are a number of other mismatches, but I don't have that much time. Next slide, please. So just for the sake of showing this room, we have done a number of RFCs in those other working groups. I have a list later, which basically tell us how we could do neighbor discovery in a more deterministic fashion, so we know better which addresses are used where. And in MANET and ROLL, the addresses move in Wi-Fi as well. So we want to be able to know what is the latest location deterministically. And the more we want to have many, many addresses on devices, the more we need to know precisely the ones that are still in use and where they are. And if we know deterministically which address is where, then we can establish routing between, well, the small routers which will form your subnet. So we have defined with RFC 8505 what we call stateful address auto-configuration, or wireless ND. And that allows basically the host to declare its address to the router without any broadcast. And you know that probably the biggest lie that's still around is the fact that IPv6 doesn't use broadcast. IPv6 uses more broadcast than IPv4. And the second thing we did is the capability to interrupt between registration in 8505 and a classical ND that we call backbone. And this is pretty much the flow that is illustrated here. If you couple the registration and ODAD, then you can connect to the network quite rapidly. And as you build this, you realize that, for instance, in this case, the 6LN, the station, can be on a network, a physical network, which is very different from the backbone. Or it could be on the same network. I mean, this really doesn't matter. Or it could be on a network where the MAC address is not breachable with the backbone. So for instance, you can do it for 82.15.4 with 8-byte MAC address on the left and still Ethernet on the right. Next slide, please. So this is the family of RFCs and draft in progress that were built on that model. So we started with the original 6LoWPAN ND, which was 6775, that we extended with 8505 to be what is really implemented today. And 2 years later, we shipped 8928. So what is 8928? That's the answer of what does sound become in this world. And if you start thinking registration where the host can declare its addresses to the routers, then it can also provide some kind of cryptographic token. And now if the routers share that information, then only a host which knows how to build and can prove the ownership of that token, if only those hosts can actually use services of any router in your subnet, then you can effectively defend your addresses against impersonation and do savvy, basically. So 8928 is savvy made simple and send made simple. Because again, the registration allows it to be simple. That's by changing the paradigm of how you use ND, you also make its securing much simpler. And 8929 is pretty much the ND proxy. With 8505, a host will tell the router, hey, I have this address. But it will also tell the router, hey, if there is some routing or some operation above you, do it for me, please. Ensure that you give me a reachability. And if the router above is effectively an ND proxy, for instance, a Wi-Fi access point doing ND proxy, then this is the signal to the proxy that it should proxy for that address. Now, the same 8505 works with multiple routing protocols. It's used for Rift, it's used for Ripple, obviously, and there is also a draft for EVPN. So it's basically the protocol independent fashion for a host to tell the router, hey, I have this address, unless there is a problem, it's my address. Please, do whatever is needed to get it routed to me. And then there is new work where we actually extend this for not only registering unicast addresses, but also multicast addresses. For those who are versed in MLD, you know that MLD also requires broadcast. So MLD also is low power, is high power. I mean, it's low power unfriendly, because it requires the host to be awake all the time, which is killing your energy, basically. So we are extending to multicast, and now we are also extending to prefixes. It's something we discussed 2 IETFs ago at 6LOW, and we'll discuss that SNAC as well. Basically, the capability for the host or the router, but the stub router, to tell the big router, hey, I have this stub prefix with me. I don't know what protocol you're using up there, but protocol independent way of saying, hey, whatever for this prefix, give it to me. Last but not least, we have this unicast lookup. So as soon as the routers know deterministically where each IPv6 address is in the subnet, then why would you broadcast an address lookup? Then again, anything broadcast, including lookup, means that the receiver must be awake. If you want to save energy, you must have the right to sleep. The unicast lookup draft says, hey, the routers know where the address is, just ask the routers. Don't ask broadcast the whole fabric, which is killing EVPN, which is killing your wireless, etc. Just do a lookup to this abstract construct that we call 6LBR. 6LBR in practice in 6LOP and ND is an abstract thing. It doesn't have to be a server. It could be seen as a DHCP server, but it can also be fully distributed with EVPN. Or it can be partially distributed with proxy ND. So it can be anything, really. It's the abstract representation of the registrar which knows all the addresses in this network. So if this abstract registrar exists, then you could ask him for any address resolution as opposed to doing a broadcast. And that's pretty much it.
Okay, we have 2 people in the queue.
David Lamparter. So you had the slide earlier where you had the 3 models with point-to-point, classical broadcast domain, and the mesh network. In that mesh network scenario, what is the actual benefit of considering this a subnet? i.e., if you're looking at, for example, RFC 7404, which describes operating without any global addresses between routers, that's pretty much the same situation. Like, you're trying to have the 64 on the mesh with the addresses for the hosts. Why not consider it a 128 on each host?
I can tell you where it's deployed. I guess it's all a matter of deployment. So this is deployed exactly like that in the smart grid, where a single of the subnets is thousands to tens of thousands of nodes. And provisionally speaking, we don't want to go ahead and give them all. How do you just go to those IoT devices and give them a different prefix? Why should we?
You don't need to give them a prefix. I think you can actually use the regular prefix advertisements and just not have the prefix be on link. So that way you have a 128 on the device.
It's exactly what we do. The prefix is not on link, and there is one big prefix for that mesh. That's what we do. I mean, I'm missing why it's not the same thing now.
That works kind of already. I mean, I'm not sure I understand what exactly. I understand what you're doing, but I'm not understanding what the problem is you're solving actually for this then.
Okay, so the piece that we are discussing here is how the host will, so it's a routing, it's routed fabric, right? It's routing inside the subnet. So far, so good. So another question is, you've got hosts everywhere in that subnet, and it's radio, meaning that at some point of time, the IP links that you can form are this, and next second, they are different, because the radio reachability has changed. So what you want to know is deterministically where the hosts are, so they need to tell the router, I'm here. And that's what we do with this neighbor discovery, making sure that the right routers know exactly what's the latest position of this host.
Okay, so you're basically trying to increase mobility times and like movement.
Exactly.
Okay.
I mean, those guys,
Okay,
everything moves
let's go
all the
to
time.
Lorenzo.
We want to know where things are.
Lorenzo?
And the addresses you don't use, we want to know they are not used anymore, etc.
Yeah, Lorenzo Colletti, I mean, you really don't want to use ND for this. It doesn't have updates. I mean, you're basically trying to build dynamic subnets with, I mean, if you're trying to build dynamic subnets where like the set of nodes on any subnet is like dynamically updatable, ND is just the wrong protocol. You started off saying, you know, that we have like, we basically have this concept of subnet that's stuck in IPv4. It's not really even stuck in IPv4. It's like built for very simple links. It's basically intended to say, okay, is this local or is it not? But like David said, basically, as soon as you get to something relatively complicated, you have to do everything off link. So
Yes.
it sounds like you're like at that point, I think that the problem that you have left once you've marked everything off link is how do the hosts communicate to the routers where they are?
Perfectly true.
But that's
exactly
a
what-
lot
what-
easier than doing all of this ND stuff. You can do that in a lot of other ways, I think. You don't have to broadcast that. And even if you do, the network can simply drop those broadcasts. Because once everything goes through the router anyway, you don't need to do peer-to-peer.
The problem is today with the NDS it stands, and even with the HCP, the router doesn't have a clear picture of which addresses are out there and where they are for the last time. So there are all sorts of hooks, of tricks, which are being played depending on the environment because of this lack of clear interaction between the host and the router. Then you may call it ND, you may call it anywhere you want, but we need something whereby a host, when it wants to use an address, will tell the router, hey, I want to use this address. When he moves with that address,
The
All
router,
right, we need to.
yeah, the host should just
we
need
need
to send the
move
packet to the router.
This to the list. We have one more talk and 9 minutes left. So Ted, thank you very much.
Thank you. So I'm here to talk to you about a new router flag or a new flag in RA messages. Next slide. The document as written right now actually proposes adding this flag to the RA flags extension option. I don't really know that that's necessary because there are 6 flag bits still available in the RA header. But either way,
Just the available.
yeah. Either way, the idea is to add a new flag. Next slide. And let's see, is that? Yeah, here we go. So the idea of this flag is basically to signal that the RA is coming from a stub router as opposed to an infrastructure router. For those who don't know, the SNAC working group is working on this new thing called a stub router that connects to the infrastructure really without, needing permission or cooperation from the infrastructure to enable like an IoT network to be accessible by devices on the infrastructure. In order to do that, it has to send RAs, but we don't want it to look to the infrastructure like its infrastructure. We want it to be distinguishable from infrastructure. So having a bit in the router advertisement that says this is a stub network and not an infrastructure network is helpful. There's a couple reasons why it's helpful. One is that it allows stub routers to notice if there is an infrastructure prefix being advertised on the link and not advertise a prefix. So in order to do IPv6 communication, you need to advertise a prefix on the link that's configurable. And if there's already a prefix on the link, then you would prefer to use that prefix. But suppose the stub router comes on the link and doesn't see a prefix, starts advertising its prefix, and then the infrastructure comes on and starts advertising a prefix. We'd like the stub router to be able to tell that it's an infrastructure router so that it stops advertising its prefix, because otherwise it's going to just think it's another stub router and keep advertising its prefix if it wins the election. So this is basically just to promote cooperation and avoid publishing extra prefixes on the link. Next slide. And the other benefit is that you might have a situation where you have a stub router or a stub network. Remember, a stub network, for those who don't know, a stub network is like a stub. It's a leaf. It's not supposed to have any further networks. You're not supposed to do routing across it or anything like that. So it'd be nice to be able to tell when you're plugged into, when a stub router is plugged into a network, to be able to tell whether it's an infrastructure network or a stub network. Easy way to do that is to look at the router advertisements. So basically, this allows us to use the stub router bit, to tell that we're being plugged into a stub network and refuse to try to use it as transit. So that's pretty much the goal. Next slide. Yeah, questions?
Hey, Lorenzo Coliti. I mean, I think this is useful, but I don't understand why it's a property of the router itself as opposed to, like, let's say the PIO and the routes that it advertises, right? Because it, I mean, what you want to do is you want to basically withdraw the PIO, and you want to or you want hosts maybe to ignore the PIO and the RIO that you get.
I don't think we want hosts to pay attention to this bit.
But then routers tend not to listen to RAs anyway.
Right.
Yeah.
I mean, mostly the consumer. Yeah, mostly the consumer of this is going to be stub routers.
They're going to send it. And what about?
They're going to send it, and they're also going to receive it because stub routers do listen to RAs.
Okay. So they're going to tell each other about their existence. Yeah.
Yeah.
You did say that on the list, I think. Yeah. But the question was like, why not apply this to the individual pieces of information as opposed to the RA as a whole?
Yeah. No, I mean, that's a good question. So let me think about that. Yeah. I mean, I would say that's a good question. I don't know the correct answer to that off the top of my head, and maybe that is the right thing to do. So we should just talk about that. Basically, what I'm trying to do here is actually figure out A, is there any objection to doing this? And B, is this the right place to do it? I mean, we could do this in SNAC. It's not in the charter right now, but in principle, it could be. I think this working group is certainly more qualified to think about the question, but on the other hand, it's a really trivial question. We're just adding a bit. So, you know, I'm perfectly happy. Yeah. What's that? Yeah, so I'd like to see this adopted either here or to be instructed to adopt it elsewhere.
Eduard?
Hello. This particular flag looks like a small piece of a big solution. And it's not possible to understand the overall in this solution, and then it's not possible to decide is this flag useful or not, because it looks like a small piece. In the topology which you have shown in the previous slide, the internet prefix should be somehow split, distributed through the site, and it's home network control protocol or something like this again, or maybe DHCP-PD or whatever. I don't understand how it's possible to judge about this without looking to whole solution.
So that would be an argument for doing this in the SNAC working group?
I don't know, but whole solution is needed, yeah.
So that's a little bit of, I mean, the discussion we had at the beginning of the spring, in some sense, I think for us to do it here, we need to hear from SNAC that this, you would like to have this from us or something like that.
Okay.
I don't think we should just take it on before that happens.
Okay, so then the takeaway would be SNAC should decide that SNAC actually wants this, and then we would ask you to adopt it. Okay.
Suresh Krishnan. So I think one of the things, the first thing you said is like, hey, there's 6 bits left. There's only 2 bits left. Just to like, so that's why I think the 51, so 6 bits have been taken in the array. So MO mobile IP, it didn't update the right RFC. So we had an IANA registry problem back in the day. So 6 bits are gone. Two for preferences, right? Like, and so on. So I think that's kind of why it needs to go in the option. So that I just wanted to clarify that. And I think like SNAC would be a good place to do it, like with 6-man review to do this. And I have no particular preference with the PIO or here. Like I think this is easier probably for lower end routers, which might be the stub routers to process. Maybe it's going to be faster than going through a bunch of PIOs, because then you have to say which PIO it goes in if you have multiple prefixes. So, and what if they conflict and so on. In this one, it becomes clear that it's coming from an infrastructure router. So I'm supportive of putting in the RA flags instead of PIO, but I don't really care that much.
Okay. Yeah. I mean, I think the reason you stated is probably not actually that crucial. So I get where you're coming from, but I think generally speaking, a stub router is only going to advertise one PIO. So hence shouldn't be an issue.
My point was not about the stub router. If the infrastructure router is advertising it, right? Like you need to.
No. The infrastructure router is completely unaware of
I understand, but you're processing the PIO, so you need to put it in PIO logic, right? The stub router can get a PIO from an infrastructure router. It still doesn't know where it's coming from, so it needs to process the PIO and expect this flag there. So which I don't want to do, right? Like, because you don't have to go through all the PIOs coming in, because the infrastructure router might
go through all the PIOs anyway.
No, but infrastructure router might have multiple PIOs.
Yeah.
You need to look at each one of them to see if it has like a stub flag.
We already have to do that. We have to look at them because we don't want to publish a PIO if there's already a usable PIO.
I understand, but you don't have to look for the stub router flag. You don't need to know if it's you need to know if it's a stub router or not, right? Because your idea is like you keep doing this until you realize it's an infrastructure router. That's why the stub router flag is there.
Right.
Like, okay. So if you put it in the PIO, you need to process multiple PIOs. But we can take this further offline, but I
Fair.
think there's
Yeah.
a better way of doing this is here.
Okay. Yeah. I don't think that, yeah.
Okay, Eric?
Yeah, Eric Ving, the SNAC AD, and looks like it's an inter-area discussion here. So basically, we are not able in the charter of SNAC to define any flags.
Yep.
Just a process thing, right? We can define the requirements, and then we need to go here, just to be clear.
Yep. Okay. We should talk about, yeah.
I think we are done.
Yeah, perfect. We are just on time. Thank you very much. Please send your comments for which we did not have time at the microphone to the list. And see you in Yokohama. Thank you very much. Yes, and please, if you say anything on the microphone, please review the meeting minutes to make sure that your comments were captured correctly, because as far as I just edit them and put whatever you wanted to say in correct way. Okay. Thank you very much.
Good.
Lessons
By the
learned.
way, I think I now remember afterwards, if you plugged the power thing in there, it would have fed power back too. These things are very cute.
Yeah, nice one.
Made by Dell.
We should provide chairs with swag like that, like souvenirs.
Say again?
Chairs should get some souvenirs like that. Okay,
But
that's it. Done.
I think we're done. So we ended up with one adoption,
call.
not two.
Well, I will use it again, but I think one.
I think one. He sort of suggested it for this, but I think we need.